Hello and welcome back to Maths Behind the Economics YouTube channel. We are still working on exponents, and in this video we're going to talk about how to divide exponents with the same bases. We will cover the rule, which we also looked at in the first video. Then I'm going to explain to you why the rule works, and I will show you plenty of examples. Let's get started. So first, let's remind ourselves how the rule works. So if we have got two numbers which have got the same bases, but they raised to different powers, and we are dividing those same bases, the result will be keeping the same base but subtracting the powers, so taking the difference of the powers. So why does the rule work? Well, let's have a think about it. If you look at 5 to the 6 divided by 5 to the 2, then by definition 5 to the 6 is basically just 5 multiplied by itself 6 times. 1, 2, 3, 4, 5, 6 times. Now, at the denominator, at the bottom of the fraction, remember fractions are division, we just have 5 squared, which is just 5 times 5. Now, what do you know about dividing fractions? Well, we know that if we have got the same number at the top and the bottom, we can cancel them out. So we can cancel out 2 from the top, and we can cancel out everything at the bottom. Now, if there's nothing in the bottom, that's just going to be 1. Anything divided by 1 will always give you 1, so we don't have to worry about the denominator anymore. But now what happened? So what we got at the top, it's 1, 2, 3, 4 5s. So we can write that as 5 to the 4, again by the definition of the power or exponent. Right, but again, how many numbers are in here? Well, we had 6 originally, and we took off the 2 at the bottom, so that's again the 6 minus the 2. Okay, so that was the case when we have got an exact number. But in mathematics, if you just show one number, that's just shown me an example. You haven't proven to me that this works in every single case. So for that, let's go back and work through the generic example. So we got a for any number, and we have got n for one number of the exponents. So what's going on in here? So we have got at the top, again, by definition, basically we just remember what a to the n means. We apply that definition here. So here we have got n numbers. We have got n numbers of a's. At the bottom, we only have m numbers, m times a's. So again, we're going to have to start doing the cancel down, and we're going to cancel down in the middle as well. And at the end, what we're going to have, we cancel down m number of them. So we're just going to have n minus m at the top, because we took out m of the top one. So that's why it's a subtraction. Okay, so I hope that you understand now why this works in the general case as well. So let's look at some examples. Let's make a bit more space, and I'm going to leave that at the top so we can always look at if in case we have forgotten this rule. So the first example, 2 to the 7 over 2 to the 3. So what's going on here? We have got 2 to the 7 minus 3. That's just going to give us 2 to the 4. Next example, 9 to the 12 over 9 to the 5th. Again, same basis, so we just have to subtract the powers. So that's going to give us 9 to the 7, because 12 minus 5 makes it 7. Next example, I've got minus 3 to the 7 over minus 3 cubed. Again, I'm going to have minus 3 to the 7 minus 3. So it's going to give me minus 3 to the power of 4. Now, is this going to be a positive or a negative answer? Do you remember what we said about the negative number taken to an even power? Well, that's going to end up being positive at the end. Because remember, you're multiplying negative twice together, that's going to give you a positive, and you do it twice because you've got 4. Right, next example, let's look at something that you might come across in generic calculations. So if you've got x to the 8 over x to the 5th, that's going to give you x to the 8 minus 5, which is x cubed. Now, once you've got used to how these rules work, you can always skip the middle step and it just jumps straight into the last answer. Let's look at the next one. So y to the 7 multiplied by y to the 4 and divide by y cubed. Now, what's going on in here? Well, before we can do the division, we can use the rule that we learned today. We have to apply the rule that was in the previous video to the numerator. So that's going to give us y to the 11 in the numerator, because 7 and 4 makes 11. And at the bottom, we still got y cubed because there was nothing in there. So now we can apply the rule that we learned today. 11 minus 3 makes 8. Last example for this video, b to the 15 over b cubed times b to the 6. So again, similarly to what we did to the example in the middle here, we're going to deal with the denominator first now, because there is a rule that I can use from previous videos. So b to the cubed times b to the 6th gonna give me b to the 9th, because 3 and 6 makes 9. Then I can apply the rule of this video, which gonna give me 15 minus 9, 6. So the final answer going to be b to the 6th. Well, I hope you found this short video useful. We looked at how and why the rule of exponents when dividing the same bases with different exponents work. Thank you for watching. See you next time. Bye.